Right now, you're moving at over 1,600 kilometers per hour, and you don't even feel it. No shaking, no wind, no warning. So what's going on? You're sitting on a giant spinning ball called Earth, and it's not just spinning, it's also racing around the sun at over 100,000 kilometers per hour. This invisible motion controls your day, your night, and even your seasons. But here's the real question. If Earth is moving so fast, why don't we fall off? Because we are moving with the Earth. The Earth pulls everything towards it with a force called gravity. This force keeps us, the air, and everything else firmly attached to the Earth. Also, the Earth's movement is smooth and constant, so we don't feel it, just like sitting in a smoothly moving train. So even though Earth is moving very fast, we don't fall off because gravity holds us down, and we are moving along with it. What is rotation? Earth rotates, spins on its axis, the invisible line running vertically down its center from the North Pole to the South Pole. It takes Earth 24 hours, a day, to make one complete rotation. As it rotates, Earth orbits, moves around the Sun. This movement is called a revolution. It takes Earth about 365 days, a year, to complete a revolution. Earth's rotation and revolution have significant effects on climate and weather patterns. Earth's rotation is also responsible for creating its magnetic field. Rotation means the Earth spinning on its own axis. The Earth rotates from west to east. That's why the Sun appears to rise in the east and set in the west. One complete rotation takes about 24 hours, one day. Think of it like a spinning top. The Earth is constantly spinning. Speed of rotation. At the equator, Earth spins at about 1,670 kilometers per hour. The speed decreases as we move towards the poles. At the poles, the speed is almost zero. But don't worry, we don't feel this speed because everything around us is moving together with the Earth. Effects of rotation. Earth's rotation on its axis, completing one turn roughly every 24 hours, creates the day-night cycle, determines time zones, and induces the Coriolis effect, which deflects winds and ocean currents. It also causes the planet to bulge at the equator, creates an apparent daily motion of celestial bodies, and influences tidal patterns. Day and night. The most fundamental effect is the alternation between daylight and darkness as different parts of the Earth rotate into and out of the sunlight. The Coriolis effect. The Coriolis effect is caused by Earth's rotation. Moving objects like wind and ocean currents get deflected. In the northern hemisphere, deflection is to the right. In the southern hemisphere, deflection is to the left. This effect influences wind patterns, ocean currents, cyclones, their rotation direction, flattened spherical shape, oblate spheroid. Rotation causes the Earth to bulge at the equator and flatten at the poles, making the equatorial diameter larger than the polar diameter. Time zones. The Earth is divided into 24 time zones, each roughly 15 degrees longitude, to account for the variation in local sun time as the Earth rotates. Apparent celestial motion. Due to the west to east rotation, the sun, moon, and stars appear to rise in the east and set in the west. Deflection of fluids or objects. Earth's rotation creates forces that change how air and water move, causing things like cyclones, anticyclones, and ocean currents. Daily tides. While tides are caused by gravity, rotation contributes to the timing and daily cycle of the rise and fall of ocean water. Sun appears to move. The sun does not actually move around the Earth. Because Earth rotates from west to east, the sun appears to rise in the east, move across the sky, set in the west. This is called an apparent motion. What is revolution? Revolution means the movement of the Earth around the sun. The Earth moves in an elliptical orbit. One complete revolution takes 365 days and 6 hours. These extra 6 hours are adjusted every 4 years. Leap year, 366 days. Earth travels along its orbital path at a speed of about 30 kilometers, 18.5 miles per second, or 107,800 kilometers per hour, 67,000 miles per hour. It takes roughly 365 days to complete its orbit of the Sun, a single revolution. Observed from the Sun's North Pole, the Earth, along with all the planets, orbits in an anti-clockwise direction. The time taken for Earth to orbit the Sun is actually closer to 365.25 days. This is why, every 4 years, we have a leap year, an extra day, 29th February, to make up for the extra quarter day in Earth's orbit. Earth's orbit is not perfectly circular, but slightly elliptical, oval-shaped. At its closest to the Sun, at perihelion, the Sun is 147 million kilometers, 91 million miles away. This occurs around 3rd January. At its farthest point, the aphelion, around 4th July, the Sun lies 152 million kilometers, 94.5 million miles, distant. Earth is orbited by the Moon, which takes 27.3 days to complete a single revolution. It, too, follows a slightly elliptical orbit. The point closest to Earth is called the perigee. The point farthest away is the apogee. Key effects of the Earth's revolution. Change of seasons. As Earth orbits the Sun, different hemispheres tilt toward or away from the Sun, causing the cycle of spring, summer, autumn, and winter. Varying lengths of day and night. The tilt causes longer days in the summer and shorter days in the winter for each hemisphere. Different temperature zones. The amount of solar radiation, insolation, received by different latitudes changes throughout the year, causing distinct temperature variations, including seasons and the heat budget of the Earth. Apparent shift of the Sun's position. The Sun appears to move further north or south in the sky throughout the year, changing the location of sunrise and sunset. The calendar year. One full revolution defines the length of 1 year, taking approximately 365.25 days to complete. These effects, in combination with the Earth's tilted axis, directly impact the migration of species and the timing of biological cycles. Variation in length of day and night and seasons. Why do day and night lengths change? The length of day and night changes because of 2 main reasons. Tilt of the Earth's axis. The Earth is tilted at 23.5 degrees on its axis. This tilt remains constant as Earth moves around the Sun. Revolution around the Sun. As Earth revolves, different parts receive different amounts of sunlight. Result: some days are longer, some nights are longer. Seasonal changes. Why do we have seasons? Earth's tilted axis causes the seasons. Throughout the year, different parts of Earth receive the Sun's most direct rays. So, when the North Pole tilts toward the Sun, it's summer in the Northern Hemisphere. And when the South Pole tilts toward the Sun, it's winter in the Northern Hemisphere. Equinoxes. Equal day and night. Key features. Day and night are almost equal, 12 hours each, everywhere on Earth. The Sun is directly overhead at the equator. 2 equinoxes. March equinox, around 21st March. Start of spring in the Northern Hemisphere. Start of autumn in the Southern Hemisphere. September equinox, around 23rd September. Start of autumn in the Northern Hemisphere. Start of spring in the Southern Hemisphere. During the equinox, no hemisphere is tilted towards or away from the Sun. Solstices, longest and shortest days. Solstice, either of the 2 moments in the year when the Sun's apparent path is farthest north or south from Earth's equator. Key idea. These are the days with the maximum difference between day and night. Summer solstice, around 21st June. Longest day in the Northern Hemisphere. Shortest night in the Northern Hemisphere. The Sun is directly overhead at the Tropic of Cancer, 23.5 degrees north. Northern Hemisphere equals summer. Southern Hemisphere equals winter. Winter solstice, around 22nd December. Shortest day in the Northern Hemisphere. Longest night in the Northern Hemisphere. The Sun is directly overhead at the Tropic of Capricorn, 23.5 degrees south. Northern hemisphere equals winter. Southern hemisphere equals summer. The Earth may look still, but it is always moving. Its rotation gives us day and night, while its revolution brings seasons and changes in day length. These movements quietly control our daily life, from sunrise to weather patterns. So, next time you see the sun rise or feel the change in seasons, remember, it's all because the Earth never stops moving.